So in the last segment, I introduced the concept of event sourcing. I talked about how it's a radically different way of both structuring your business logic and persisting your business entities. It's a very event-centric approach. Most notably, the way in which you store your business entities in a database is not by storing the current state, but by storing the sequence of state-changing events. And then when you need the current state, you load the events and you replay them. And I also talked about how that has certain benefits, so that when you save an event which corresponds to an update, that event can get published, and subscribers can consume that event, update their own state, and publish more events. So you end up with this, it ends up being a fairly straightforward way of reliably implementing an event-driven, eventually consistent business transaction. And there's some other uses as well that I described. So in this section, I want to talk about how you can design a domain model that's based on event sourcing. So I think I read the book Domain-Driven Design back in, I think it was 2003 or 4. It felt like a very, very long time ago. Fantastic book, highly recommend it. And what's interesting is that the concepts from that book are applicable today when we're building modern microservice-based applications as they were back then. So in the book, it actually describes a set of building blocks, which are sort of roles that objects play. So there's an entity object that's a persistent object that has an ID. So that could be an account, an order, a customer, and so on. Then there are also value objects that are objects that don't have any identity. They're just like little wrappers around values. So you could have a money object that has an amount and a currency. You can have services that contain business logic that doesn't belong in an entity. And then you have repositories that abstractly represent collections of entities, but in practice are implemented by data access objects, so they're accessing database tables. And then there's this curious concept of an aggregate, which 10 plus years ago, it really didn't sort of resonate with me. But then it turns out that today, if you're building applications that are based on microservices or NoSQL databases, then aggregates are a very, very essential modeling tool that you should have in your toolbox. Okay, so what's an aggregate? So an aggregate is a graph of objects which has a root entity and one or more other entities or value objects hanging off it. It typically would be a core business entity in your system, a customer, an account, an order, and a product, and so on. So on the slide, I've got an order aggregate. So there's the entity representing the order, and then hanging off it are some other value objects that are like order line items and the delivery address, and so on. So it's really just a little chunking of your domain model. So in itself, that's not exactly profound. But where it gets interesting is that there are some rules around aggregates. So one of them is that references to other aggregates are via primary key only. So in this example, an order references a customer. In a normal object model, an order would actually reference a customer object, just a regular object reference. But the rule with aggregates is that you can only have the primary key. So in this example, we have the customer ID. Likewise, an order line item references the product by its product ID. And later on, you're going to see why that is such a profound change that's really essential to writing domain logic in a microservice application. And then another little feature is that an aggregate might have a partial copy of other aggregates data. A great example of that is an order line item might actually have the product name just for convenience, so you don't actually have to load the product to know what the name of that line item is, but it would also have the product price. And in this case, there's an argument to be made that taking a snapshot of the price at the time the order was created is actually meaningful, right? An order represents a contract with the customer, and they've agreed to a particular price, so it makes sense to snapshot it. So why is this such a big deal? Well, the reason it's a big deal is that you look at a typical domain model, it tends to be this bird's nest of objects where everything references everything else. And so actually splitting it up, partitioning it into different microservices is actually a challenge, because there are these object references everywhere that would cross service boundaries. So if we actually take an aggregate-oriented view of our domain model, we actually split the domain model up into separate aggregates with only loose connections between them. The references between aggregates are now by primary key as opposed to being by object references, so there's no problem with splitting them up and putting them in different services. So it makes it very straightforward to do this partitioning, where the order service contains the order aggregate, the customer service contains the customer aggregate, and the product service contains the product aggregate. It's very straightforward to partition things up, which is fantastic because that's the whole point of microservices. So that's one thing. Then there's another really interesting rule, which is a transaction should only update one aggregate. And when I read this just made no sense, because I was building monolithic systems that had a relational database, so I could begin a transaction, update any number of aggregates or any amount of data in my system, and commit the transaction. And that was pretty straightforward. But if you think about in a microservice, the scope of a ACID transaction is now limited to exactly one service, right? We've talked about how if you want to have transactions span multiple services, it must be an eventually consistent event-driven workflow. So aggregates give us a way of modeling that. The update that happens local to a service is the update of exactly one aggregate. So our transaction boundaries now look like this. The order service can update an order, customer service can update a customer, and a product service can just update products. So that has a number of consequences. If something needs to be done atomically, then it has to fit within an aggregate, which means that you carefully have to think about how you design your aggregates, and I'm going to talk about that more in just a second. But it also means that the scope of a transaction really is just one aggregate. So very powerful modeling concept from kind of a while ago that fits both the constraints of a microservice architecture, and it also fits the constraints of a NoSQL database where you can only update one thing at a time. And in fact, NoSQL databases have been referred to as aggregate-oriented databases. So this does mean, though, that you actually have to very carefully choose what your aggregate boundaries are. And in fact, you have a choice. So for example, you could make the entire system, customer and order and product, one aggregate. That's likely to not scale, and it's likely to offer a very bad user experience, but you could do it if you wanted to. An intermediate option would be to make a customer and their orders one aggregate, and then all the products as separate aggregates. And that could actually work. You could imagine using MongoDB to store the customer and all of their orders. that could work reasonably well. You always have to remember that because the updates of an aggregate end up being done serially, you can't update different parts of the same aggregate concurrently. So if the user experience means that you want to have multiple users working concurrently on things, then ideally they have to be partitioned into separate aggregates. And then, of course, there's the finer grained option where customer, product, and order are actually their own individual aggregates. So you have a choice. There's a spectrum, and you have to choose the aggregate granularity that's sort of appropriate to your requirements. So let's have a quick look at these domain events. They record state changes and other notable things that happen to an aggregate. And they're part of the public API of the domain model. They're not really, even though they're published by a given service, they're actually consumed by other services, and so it's sort of public. It's kind of part of the public API. They tend to they're just sort of simple value objects. They might have some metadata, like the event ID, the ID of the entity that sent them. Then they might have attributes that are kind of required by the business logic to be there. Like when you add an item to a shopping cart, you need to know what the item is. But then there's a concept of event enrichment where you add in extra attributes that are not useful to the aggregate, but they're useful to any consumers of the event, like the name of the product and the product price. Here's an example of an order created event. It's very simple. It just actually has an order total and a customer ID. There's a lot of boilerplate because in Java you tend to have to define equals methods and then a hash code method and then getters and setters. If this was Scala, for example, it would just be a one-line class definition. It kind of pains me looking at the verbosity of Java. And then commands, so those are created by a service from an incoming request. They're processed by an aggregate, and they're immutable, like events are. And they're typically just a collection of value objects that are used for validating the request and creating the event and maybe doing auditing. And so here's an example of a command class. Is the creating a customer. So it just says create this customer with this name and this credit limit. And once again, there's a bunch of boilerplate. That if this was a Scala case class, it would just be one line. So hopefully I've given you a sense of what aggregates or what business logic looks like, or some of the steps for designing business logic, and illustrated how the concept of aggregate, which is quite an old idea, is very applicable to microservices. And we kind of briefly looked at event and command objects. There are actually different programming models for writing the aggregates themselves. I've created examples using a traditional Java object-oriented style where you have mutable domain objects. And then I've got a couple of different Scala programming styles, one which is very, very functional, and then I have another one that's sort of half OO, half functional programming. But in both cases, they have immutable domain objects. So hopefully I've given you a flavor of what this looks like, and in the next segment, I'm going to walk through some example code.